Hello everyone, I am Nikhil Prakash from the Engineering Geology Group of ETS Zurich. With this very short presentation, I would like to introduce you to my work on mapping landslides using deep learning methods from satellite images. Okay, landslides are natural hazards which concerns the mountainous regions of our planet. They are a source of threat to the population which lives in the hilly regions or regions with very steep slopes. These landslides can be identified on satellite images by observing very characteristic surface features which are associated to ground deformations or ground movements. However, identifying these landslides is a very challenging task. This is because the surface features which help us identify a landslide varies very widely. They can also be very different in different sources of data, region, or type of event. The object-based and the pixel-based methods have been widely used to automatically map landslides from EO data. We have developed a new deep learning-based methods to map these landslides and have also compared this method to the traditional object-based and the pixel-based approaches. The details about the machine learning models and the results can be found in our new remote sensing paper which was published in January. You can pause this video now and scan the QR code to directly go to the paper. To test our algorithms, we selected a study area in Oregon, USA. The landslide inventory of this area is called Slido and it was acquired from the Oregon Department of Geology and Mineral Industries. This inventory is a collection of historic landslides which have been mapped in detail for our Douglas County study area in Oregon. Most of these landslides were old and it was difficult to observe them from optical images, but they could be observed easily from LiDAR-derived digital terrain models. Here are examples of what a landslide is expected to look on the hillshade of bare earth digital terrain models. We tested our algorithm by training them on features which were derived from LiDAR images and the optical images. For training, we divided our study area into two regions. We used one part for training and validating our models, and once we have a model trained, we use them on the other half of the dataset to test it and evaluate its performance for comparison. Here are the results of all the three landslide mapping methods. The map shows the true positive output of the three methods in three different primary colors. The secondary color implies that the area has been correctly identified as true positive by two methods, and the gray color implies that the area has been identified as a true positive by all the three methods. The landslide boundaries from the Slido inventory has been shown as dotted polygons. If you see closely, you can notice that all the big landslides have been identified mostly correctly by all the three methods. You could see that the deep learning based methods and the object based methods have missed out identifying these smaller landslides. We could observe a lot of blue color detection, cyan and purple color detections in this testing area, which implies that there has been a lot of detections from deep learning methods which was not detected one by one of the other traditional method or both the traditional methods. Now this is a map which shows a comparison of the false positive predictions of all the three methods. The red color is the false positive from the pixel-based methods which we find is scattered all across the testing area. If the landslides are located very close to each other, we see that the methods, especially deep learning and object-based methods, try to predict them together as one big landslide instead of multiple small landslides. Overall, the deep learning performed the best and had a highest probability of detection of 72%. We tested our deep learning algorithm in a totally new geo-environment setting. Here we try to map rapid and recent landslide which occurred as a consequence of a heavy rainfall during the monsoon seasons of 2015 in Myanmar. We trained our deep learning algorithm on a set of before event and after event optical images, along with more information from the DEM. We were able to achieve a probability of detection of 88% with the probability of false detection of only 2%. It is incredible to see a deep learning method which has worked well for mapping landslides from digital terrain models also work quite well for mapping landslides from optical dataset. I really believe that these deep learning methods would be the new future for mapping landslides from satellite and Earth observation images. Thank you.